Welcome to the Syntho platform. You can log into the platform using the single sign-on login option or with your email and password. Once we have logged in, we then arrive on our workspace panel. From this panel, you can create your workspace by connecting to your database, or you can open an existing workspace. You can connect to a database by selecting this option and filling in the credentials for your source database. That's typically where you have the original privacy-sensitive data stored. So that can be your prediction database, for example. Then you fill in the details for the destination database, which is where you're going to write the synthesized data or the identified data. Finally, you have to give a name to the workspace. Once everything is set up, you can click on Create the Workspace. After that, you are forwarded to this Workspace Overview panel, where you see all the workspaces that you have created before. You can open any one of them to start configuring your data generation job. Our platform has three main features: AI-generated synthetic data, smart de-identification, and test data management. One of our key features for AI-generated synthetic data is that we support non-time series and time series synthetic data, which is more complex and facilitated by our in-house developed sequence model. We also provide a quality assurance report to evaluate our synthetic data on various industry-standard privacy and data utility metrics. Additionally, we offer multiple database connectors for easy data integration. For smart de-identification, we begin with our PII scanner, which uses AI to quickly identify the most sensitive columns in your database. These columns can then be replaced with synthetic mock data. With over 150 different mockers available, you can apply consistent mapping on those mockers to ensure that input values are consistently mapped to the same output values, maintaining data integrity across different data generation jobs, tables, and systems. Our PII scanner also de-identifies columns containing open text information. For test data management, you can benefit from both de-identification and AI-generated synthetic data. Additionally, rule-based synthetic data allows you to generate data from scratch based on specific business rules and constraints relevant to your organization. Another important part of test data management is subsetting, which allows you to create referentially intact subsets of your database. This is particularly useful when working with extremely large databases in production settings. Subsetting enables you to shrink your database to a smaller size while maintaining referential integrity, preserving its value for testing. This is our job configuration panel, where you configure your data generation job using table and column level configurations. On the left, you'll find the table level configurations. Currently, all tables are listed as excluded, but you can also decide to either de-identify or synthesize tables by dragging them into different modes. Once you have selected the desired mode for your tables, you can go into specific settings for that table. For instance, you can choose to generate more rows, allowing you to expand your dataset beyond the original input. On the column-level configurations, you'll find a range of options. You can opt for AI-powered generation, duplicates, exclude specific columns, or apply mockers to replace certain values with mock values. With these powerful configurations, you can tailor your data generation to suit your exact needs, ensuring high quality and diverse datasets. Here you can see several columns that have already been labeled as PII by our scanner. If we navigate to the PII Scanner tab, we can review the results for all columns identified as PII. In this example, we have columns for address, driver's license, first name, and last name. On the right, you can see the confidence level indicating how likely it is that each column contains PII. To confirm that these columns contain PII, you can click the Select button. This will allow you to preview some of the values identified. If there are any mismatches, you can easily remove them from the PII list. Our foreign keys feature helps you describe relationships between tables. In this example, the patient's table does not have any foreign keys defined. However, if we look at the allergies table, we can see it has two foreign keys, one to the encounters table and another to the patient's table. If your database does not already have foreign keys defined, You can add multiple foreign keys at once by uploading a JSON file. Alternatively, you can start a foreign key scan, which offers various options to enhance the accuracy of the scan. There is also a toggle to show only the foreign keys that you've manually added through the platform. If you disable it, you'll also see the foreign keys automatically inherited from the source database. If you want to work together with your colleagues, or maybe even with external parties, you can easily share your workspace and all the configurations you've set by going to the Share This Workspace option and selecting the person that you want to share it with. You can assign particular rights this user has, including access rights to specific data, which determines whether this user can see the actual source data or not. To deploy our platform within your secure infrastructure, we offer several flexible options, utilizing Docker and Kubernetes for deployment. This flexibility allows you to deploy our platform anywhere, in an on-premise environment, on cloud services like AWS, Azure, or Google Cloud, or even in a private cloud. We also provide a hosted version. We recommend deploying via Kubernetes due to its stability and scalability benefits. Once everything is set up, the data flow is straightforward. The platform runs in your chosen secure environment. After deployment, you can connect to your source database, which may contain your production data, through any of our supported connectors. After configuring your data generation jobs, the platform generates new data or de-identifies your existing data, writing it to a destination database via our destination database connectors. This creates an end-to-end integrated workflow that is flexible, easy to set up, and automatically synchronizes data changes. We support most leading databases with an ever-growing list of connectors based on customer needs. The deployment process varies depending on your data. For instance, the amount of memory required depends on your data size. We can provide estimates based on more detailed information about your data. This also applies to the number of virtual CPUs and disk storage needed, with a preference for SSDs due to their speed. So this is for the AI cluster nodes, where most of the heavy lifting happens to generate your data. We typically have a separate node for running the application, which includes the front end and back end, ensuring smooth interaction with the platform. These nodes should run on Linux OS. For production settings, Kubernetes is recommended for its stability and scalability. For non-production or test setups, Docker or Docker Compose can be used. After deployment, we provide a comprehensive customer support and success services, which start with a deep dive and decision-making session with your team to align on requirements. This is followed by a kickoff session to further refine requirements and define the suggested infrastructure for deployment. We also discuss communication, workflow, and planning. The deployment proceeds in phases, followed by our Syntho bootcamp session, which is valuable for quickly familiarizing your team with the platform's features. During this bootcamp, we will synthesize some data together, ensuring you are fully ready to use the platform. Post-bootcamp, we continue to provide support to ensure your success with the platform. These are the main steps, and we look forward to working with you. At Syntho, we offer feature-based pricing with no consumption-based charges and free deployment. We provide a Syntho engine license tailored to your needs, where you can define the number of users and connectors required. You can choose the features you want from our platform's various solutions and select the level of support you prefer from the Syntho team. We then enter into a one-year agreement with a fixed monthly pricing plan, ensuring predictable payments. Let's explore the AI-generated synthetic data feature, which is typically used for analytics and machine learning model training. Here's how it works. You start by dragging the table you want to synthesize under the Synthesize section. Once you've done that, you let the AI do the work. All the columns will be automatically fed into our generative AI model, which preserves the relationships and patterns in the dataset and regenerates them in a synthetic dataset. If you go to the column settings, you'll see that AI-powered generation is applied to all the columns. At this point, you can decide if you want to change the number of rows. You can increase this number if needed and set the number of rows the platform will generate. Once you're happy with your settings, you can proceed to generate the synthetic data. You'll be taken to the job summary page, where you can see which tables are being synthesized and which are excluded. Finally, you can start the generation process by selecting the Start Generation button. With synthesization, you are able to generate more rows than you originally had as input. This can be useful for machine learning model training, where there might be relatively few observations of certain features or columns in your dataset. If particular groups of people are underrepresented, you can generate more output data to ensure these minority groups are better represented and boost the performance across your entire dataset. To do this, simply change the number of rows to generate. For example, you can set this to 1 million. The trained generative model will then produce and write 1 million rows into your output database rather than the original number of rows. This upsampling combined with AI-powered generation can significantly improve your analytics and machine learning model performance. Let's explore how AI-generated synthetic data works for time series or longitudinal data. In this example, we have a time series dataset for baseball players consisting of a players table and a seasons table. The players table contains information about the players, while the seasons table contains the sequence or time series information. For each player, we have multiple observations across different seasons. To preserve this sequential information, we developed a sequence model. To use this model, you can select the Generate option and enable sequence modeling by pressing this button. Once enabled, you can start the generation process and wait for the sequence model to complete the data generation. So how does the synthetic data that we generate look like? Let's have a look at the original data that we used as input for the synthetic data generation. Here we have the original patients table where we see a variety of their corresponding information. Now let's examine the synthetic version of this table that we just generated. You can see that the synthetic data looks very similar to the original data. However, it is completely newly generated using our generative AI models. If we compare the two, you'll notice that the rows are entirely artificially generated. Despite this, the relationships, patterns, and properties of the original data are still reproduced in the synthetic set. For example, if we look at the birth and death date, you can see that the death date is always later than the birth date. These are typical relationships that are preserved in synthetic data. More complex relationships, such as the correlation between latitude and longitude or between location and healthcare expenses, are also maintained. In some locations, healthcare expenses might be higher, while in others, they might be lower. These patterns are all preserved in the synthetic data. This is the essence of AI-generated synthetic data. You let the generative AI do the work to create entirely new synthetic data that still looks and feels like the original data. Now let's take a look at our quality assurance report where we compare the original and the synthetic data in terms of data quality and privacy. First, we have the privacy metrics, comparing 3 different metrics between the original and synthetic data. The first metric is the identical match ratio, which looks at identical matches in the synthetic data relative to the original data. The next metric is the distance to closest record ratio, which considers not only identical matches, but also near matches from the synthetic data to the original data. Finally, we examine the nearest neighbor distance ratio, focusing specifically on outliers to ensure they are not reproduced in the synthetic data. Next, we move to the univariate distributions, comparing the original and synthetic data column by column. For example, if we zoom in on the gender column, we can see that the original data has a roughly 50% female-to-male ratio, and in the synthetic data, it's virtually the same. We can also explore other columns, including numerical columns and date-time columns, which are visualized as line graphs. These graphs show how well the original and synthetic data overlap, indicating that the synthetic data accurately reproduces the patterns of the original data. To go more in depth, we analyze correlations between specific variable combinations. For instance, when comparing the original and synthetic data, the correlation between variables such as county and city remains strong in both datasets, which is exactly what we aim to achieve. These results are consistent across various industries, including healthcare and finance. The metrics are industry agnostic, demonstrating that your synthetic data remains valid and can be effectively used for your use cases regardless of the sector you operate in. Let's look at some of the evaluation results from the experts at SAS on our synthetic data. How did they do this? In a project aimed at predicting customer churn in a telco company, they used a target dataset of 56,000 customers with 128 different columns to predict whether customers would churn or not. They trained 4 different types of prediction models and evaluated how well the original data performed on those models, how well anonymized data performed, and how well synthetic data performed. In the results, we see that the original data always produced the best results. However, the anonymized data had significantly inferior results, with an area under the curve value close to 0.5, indicating that the model was predicting at random, so it did not perform well. On the other hand, the synthetic data's performance was nearly identical to the original data. These are the main findings. Synthetic data performs almost as well as the original data, while anonymized data shows the worst performance. Another benefit of synthetic data is that it is easy, fast, and scalable, which is a significant advantage over data anonymization. At Syntho, we provide a smart de-identification solution to successfully de-identify your entire database, which essentially means removing the most sensitive data from your database and replacing them with mock values. Let's start by dragging all the tables we want to de-identify into the de-identify section. As you can see, some columns are immediately marked as PII and highlighted in red, indicating their sensitivity. But how do we know which columns are sensitive? We first start by running a PII scanner. In the PII tab, you'll see the results from a previous scan we ran, showing the columns identified as PII. On the left, you'll see the column labeled as PII, and on the right, you'll see the PII scan results with a confidence score indicating how certain the scanner is about the labeling. To run a new PII scan, click on Scan at the top. You can choose between a shallow scan, which only considers metadata, and a deep scan, which also analyzes the data itself using AI models, specifically entity recognition models, to determine if columns contain PII. Once we confirm which columns contain PII, we can replace them with mock values. For example, if a column is marked as address, we can apply an address mocker to de-identify it. We follow the same process for other columns, such as first names. You can also preview the values and apply the appropriate mockers. This is how we can successfully de-identify the database. Additionally, you can perform these actions from another screen. In the Job Settings panel, you can review the columns labeled as PII and replace them with mock values. The identified PII columns are also listed in our documentation, which we always refer to, ensuring they contain all the relevant PII or PHI for you. You can also add any custom PII or PHI entities based on your preference using the PII tab. For instance, if we want to identify the passport column as PII, we can manually do so here and then replace it with mock data, or we can also exclude it in this case. Now the passport column has been added as PII and successfully replaced. For instance, let's apply a mocker to the Social Security number column. You can do this by adding the Social Security number mocker into the mock data settings to replace this column with mock values. We can do the same for driver's licenses and passport columns using advanced mockers to define the data structure ourselves. For example, a driver's license column might always start with S999 and end with 5 random digits. To create this structure, go to the mocker settings, select custom text, and define the structure accordingly, starting with S999 and ending with 5 random digits, which is done by inputting hashes. If you hover over the icon on the right, you can get more information on how to use this mocker. Then you can preview the values and adjust settings, such as introducing some missing values by changing the blank percentage. Once satisfied, select Confirm, and the column will be successfully de-identified. Moving on to the next column, the last name column, let's replace it with a last name mocker. If we preview the values, you'll notice they are in English by default. However, if you want to use different language values, you can easily switch. For example, to use Dutch locale values, simply select the Dutch option. You can also choose other locales, such as Japanese. This gives us a variety of options to replace the data in this column. For this demonstration, I'll stick with the English locale and replace the last name column with mock values. Additionally, we can apply more advanced logic, like rule-based synthetic data, for more precise data generation. Now that we have seen how we can de-identify our columns, let's say we want to de-identify columns by applying mockers while also ensuring consistency so that the mocked values can be linked across different data generation jobs where we've de-identified the data. Let's look at this example where we have a city column with 3 values of Boston. We want to consistently map these original Boston values to new mock values, ensuring that the output mock values can be linked to other data generation jobs where the same settings have been applied. If we preview the values, we see random values being generated, but if we enable consistent mapping and then preview the values again, Boston is now consistently replaced with this particular mock value. This consistency works across different data generation jobs and tables, maintaining data integrity and consistency across those tables and systems. Test data management typically involves working with large production databases and multiple interrelated databases, which come with numerous challenges. Our platform is designed to handle these challenges efficiently. Let's dive into how we facilitate this process. In test data management, we often deal with privacy-sensitive data. As with standard de-identification, you would start by de-identifying the most sensitive columns in your database. You can do this by navigating to the PII tab, running a PII scan, and then de-identifying the columns identified by the scan using the suggested settings. You can go through this process one by one until you are satisfied with the applied settings. Additionally, you can add custom PII columns that you consider sensitive. Ensuring consistency of de-identified data across different systems is another crucial challenge in test data management. This consistency allows you to test and proceed with your test cases seamlessly. We handle this by preserving key relationships across your tables, automatically using the foreign keys feature. For instance, in the allergies table, there are 2 relationships with other tables in the database. Our platform ensures these relationships are preserved in the generated data. Beyond key columns, we also need to maintain consistency in non-key columns. For example, in this city column, with values like Boston. If we want to de-identify this column, while ensuring that Boston is consistently mapped to the same output value, we can do so by selecting the column and applying a city mocker. Initially, this generates random mock values, but by enabling the consistent mapping feature and previewing the values, we ensure that Boston is consistently replaced with the same new value. This is essential for maintaining consistency across tables and systems. Handling large amounts of data is another significant challenge in test data management. Production databases often contain vast quantities of data. For example, we might have a table with 2.15 billion records. Our platform is equipped to handle such large data sets efficiently and optimize processing speed. One way to achieve this is through parallel processing. In the advanced generation settings, you can set the number of connections to increase parallelization, allowing multiple tables to be processed simultaneously. Adjusting read and batch sizes can also enhance processing speed. Balancing these parameters with hardware capabilities enables efficient handling of large databases. These are some typical scenarios in test data management that our platform addresses, ensuring efficient and effective handling of your test data needs. Let's explore rule-based synthetic data. This feature is useful when you need to define custom logic to populate columns with data. This could be necessary for testing specific rules or when you don't have any production data available. In such cases, you can use our rule-based integrator features, particularly the calculated columns. For example, let's define logic to fill the first name column based on values in the prefix column. In this prefix column, we have values like Mr. and Mrs. We want to fill the first name column with a male name when the prefix is Mr. and with a female name when the prefix is Mrs. How do we do this? First, we go to our rule-based data feature, which is the calculated column, and start writing an if statement. Here we have various functions available to define our logic, but we'll use a basic if statement. We'll specify that if the prefix column equals Mr., we will apply a male first name mocker. If the prefix is Mrs., we will apply a female first name mocker. When we preview the values, we can see that based on the prefix, the first name column is populated accordingly. This allows us to create custom logic for our data. We can use a similar approach for columns without any data, such as the suffix column. Let's fill it based on the prefix column again. We go to the calculated column and write another if statement. We specified that if the prefix column contains Mr., we will fill this column with a male suffix value. Otherwise, we will fill it with a female suffix value. Previewing the values, we can see that the suffix column is now correctly populated. Using these techniques, we can flexibly fill our database with relevant data for testing purposes based on the logic and rules we've defined. One of the key challenges in test data management is handling large data volumes. When working with production databases, you often encounter very high volumes of data, which can be difficult to manage. To address this, we offer a subsetting feature that allows you to shrink your high-volume database into a referentially intact subset. This process is more complex than it might seem. It's not just about reducing the size of tables, it's also about preserving the relationships between tables. Here's how it works. You can select the number of rows to generate for a particular table. For instance, if your original table has over 2 billion records and you want to reduce it, you can specify the desired number of rows. Let's say you want 100,000 rows as output. Our platform will automatically adjust the related tables accordingly, ensuring all relationships are maintained. Our platform handles this by examining the foreign keys in the database. For example, if you look at the allergies table, you'll see it points to the patients table. When we reduce the size of the patients table, the allergies table is also proportionally reduced. This is how our subsetting feature works to manage your database effectively while preserving the integrity of your data relationships. If you have any questions or anything you would like to share, feel free to reach out to us via our website or schedule a live demo with us. Thank you for watching.